Hi everyone, how are you guys doing? So in today's session, we will continue our discussion about ARP. So if you have not watched my first video on ARP, I strongly recommend you to watch it first for better understanding. So let's get started. So this is a ARP packet. Looks colorful, isn't it? So we have different fields here with varying lengths. ARP packet is 32-bit wide, which is 4 bytes. ARP packet size is 28 bytes. First field, what you see is a hardware type field, which is 16 bits, 2 bytes, and so is the next field, protocol type. Hardware address length and protocol address length are both 8 bits, 1 byte each. Opcode is 16 bits, 2 bytes. Source hardware address, target hardware address, which is for our MAC address, 48 bits, 6 bytes. Sender protocol address, target protocol address, which is for IPv4 address, 32 bits, which is 4 bytes each. Let me try to explain the fields in the next slide. Hardware type. This field basically says what is my underlying network type used to carry the ARP and what would be the layer 2 addresses I will be carrying. Value of 1 represents hardware type field, which is Ethernet. We have different hardware types, so please refer the top chart on the right hand side. Next is the protocol type. It represents what is the layer 3 protocol used for addressing. So for an IPv4 address, we have a hex value of 0800. Next is hardware address length. This specifies the layer 2 address length used in the header. For a MAC address, it is 6 bytes. Protocol address length. This specifies layer 3 address length. IPv4, 4 bytes. And next comes a very important field, opcode. This tells us what type of a ARP message the packet carries. Opcode values range from 1 to 9. So you can refer this chart for other message types. Sender hardware address. This is layer 2 address of the source machine, MAC address, 6 bytes. Sender protocol address, IP address of the source machine, 4 bytes. Target hardware address, layer 2 address of the destination machine, 6 bytes. Target protocol address, IPv4 address of the source machine, 4 bytes. So let's say computer A on the left hand side with an IP address of 10.00.11 and MAC address ending with all A's wants to communicate with the computer on the right hand side B with an IP address of 10.00.22, MAC address ending with all B's. To do so, laptop A starts by preparing a ARP packet. Let's build a ARP request. Since my underlying network is Ethernet and I'm carrying Ethernet addresses, hardware field will have a value of 1. As I'm carrying IPv4 addresses, protocol type field will have a value of hex 0800. Then comes the hardware address length. MAC address is of 6 bytes, so it will have a value of 6. Next comes the protocol address length. So since we are using IPv4, it will be 4 bytes in length, hence the value 4. The next field is the one which tells us what type of a ARP packet this is. Since it's a ARP request, it will have a value of 1. Next, the computer puts in its local MAC address in the sender hardware address field and puts its IP address in the sender protocol address field. Since the PC does not know the destination laptop MAC address, it fills in all zeros in the target MAC address field and puts in the destination IP address in the target sender field address, which is 10.00.22. So with all these fields filled in the ARP packet, the packet gets wrapped in an Ethernet header and gets onto the wire towards the switch. Notice the layer 2 destination is all Fs. This is a special reserved MAC address indicating a broadcast frame, which means send it to all. Now that the computer B has received a ARP request from computer A, it has to send back a response. So let's build the ARP response packet. The first four fields remain the same, and the change happens in the opcode field where it gets a value of 2, which is ARP response. Then the sender hardware address gets filled with the local address of the computer B, followed by sender IP address 10.0.0.22 in the sender protocol field. Next, it fills up the computer A's MAC address, which it learned previously via a ARP request in the target MAC address field, and finally fills up computer A's IP address in the target protocol address. Now the packet gets wrapped in an Ethernet frame with the source and destination MAC and gets forwarded towards computer A. Note, this time no broadcast MAC of all Fs, as the frame is sent directly towards laptop A via switch. This brings us to end of this session. I will be covering few more topics in the coming days, so please stay tuned. Hope this session was informative. Have a good day. Thank you.